All right, we want to replace the three forces acting on the structural support with a wrench, and then specify the point P in the XY plane through which the line of action for the wrench passes. Note the 12 kip force is applied at the midpoint of member AB and lies parallel to the X direction. And then we want to illustrate the wrench moment and resultant in an appropriate sketch. All right, so let's just begin by really going through the steps. This is a fairly straightforward problem, and we'll just follow our steps to forming a wrench. And step number one is to write the resultant. So R is the sum of the forces. And for this one, we have a 12 in the I and an 8 in the J. And then this 16 kip force is in the minus K. And those would be kips. So there is the resultant. All right. Our second step would be to write the moment that the forces make around the origin here at O. So the moment around O would be equal. All right, so let's think about the axes together. Notice the 16 kip force is going to pass through the origin. It is not going to make a moment around any axis. The 12 kip force is parallel to the X direction, so it won't have any effect. The 8 kip force can produce a moment around the X axis. It goes over top of it by 14 feet and would produce a moment in the negative X direction. So we have a minus 8 times 14 in the I. For the y-axis, the 8 kip force is parallel and has no effect. The 12 kip force, since we know it's applied at the midpoint of this member here, then the vertical height that the 12 kip force goes over top of the y-axis is half of the total height here of this vertical distance from A to B. So that's 7 feet. It is going to produce a positive moment around the y-axis. So we have plus 7 times 12 in the J. And then if we think about the moment that the 12 kip force makes around the z-axis, that's the only one that can, since the 8 and 16 both hit it. The horizontal distance that this point is at D away from the z-axis is half of the horizontal distance between O and B, and so that must be 6 feet. It is going to produce a negative moment around the z-axis by the right-hand rule, so minus 6 times 12 in the K. And that would tell us that the moment around O is a minus 112 in the I, plus 84 in the J, and then minus 72 in the K. And the units are pound feet. So there's R and M. All right, step number 3 is to write the unit vector in the direction of R. And so that would be 12i plus 8j minus 16k, and then each of those terms divided by the magnitude of r. And if you did that, then the unit vector would become 0.557i plus 0.371j, and then minus 0.743k. Step 4, we can write the scalar version of the wrench moment. So M is equal to MO dotted with N. Remember, the wrench moment is the part of the moment around O that the resultant is incapable of producing. And so that would just be the amount of M in the direction of N, which is easily found through a dot product. So this is minus 112 in the I, plus 84 in the J, minus 72 in the K, dotted with 0.557I, plus 0.371J, minus 0.743K. And as we do this dot product, we would have the I on the I, so that's a minus 112 times 0.557. We have the J on the J, so that's an 84 on the 0.371. and then the k on the k. And you would find that m is equal, if you do the math and add that up, to a positive 22.3 kip feet. Let me correct one thing really quick. We said pound feet back here for the moment. That's actually kip feet. I'm sure you've already thought that to yourself as you watched the video. Just had a little typo. All right, but m is 22.3 kip feet, and it is positive. Let's go ahead and write that as a vector. And so step 5, m as a vector is m times n. So this is 22.3 multiplying our unit vector. We'll just copy that down again. And if you write that vector out, m is 12.41 in the I plus 8.28 in the j, and then minus 16.55 in the k. Kip feet. We'll get this one right. All right. The next step would be to identify the plane that we're interested in, and that's always in the problem statement. The problem statement says the xy plane. And so our position vector looks like some x in the I plus some y in the j. And the only thing that remains is for us to solve the equation. So step 7, if you will. I think we can maybe zoom out here and get it. So step 7 is MO is equal to R cross the resultant plus our wrench. And let's substitute. So MO, we have a minus 112 in the I. We have plus an 84 in the J. We have a minus 72 in the K. And that's equal. We have XI plus YJ. And we're going to cross that with the resultant, which is 12I plus 8J minus 16K. And then we're going to add to that the moment we just wrote. 21I plus 8.28J and minus 16.55K. So again, just copy everything down at first. Don't try to do too much. All right, so let's focus on this equation now. Let me clean that up just slightly. Okay, so let's worry about the cross products. So we have I cross I is nothing. I cross J is going to be a K. So we have 8x in the K. And let's just focus on that for right now. So feel free to draw your triangle. A counterclockwise journey around is positive and a clockwise is negative. All right. The next one is the I cross K component. I crossed with K is a negative J. So we have a minus 16x, and then it's a negative J. Then we have the J crossed with I term. So that is a 12 and a Y, and J cross I is a minus K. I have the J cross J, which is nothing, and then I have the J cross K term. So that's a minus 16Y, and J cross K is a positive I. Alright, so again, I've selected colors here. I've used orange for K, and blue for I, and green for J. So now I'm going to recopy the rest of my equation down. So let's pull down the I stuff. So I have a minus 112 here. And then over here I have a plus 12.41. And then in the J direction we have the green. And in the green, I've got the 84 on the left, and then the plus 8.28 on the right. And then I've got an orange for the K. And then the only other one is minus 16.55. All right, so this is a vector expression here that we have written, and all we got to do now is collect the terms. So let's collect on the i's first. So we have a minus 112 on the left equals a minus 16y plus 12.41 on the right. In the j direction, we have the 84 on the left, and then we have a positive 16x on the right, and a plus 8.28. And then in the k direction, we have a minus 72 on the left, and then an 8x, minus a 12y, and then minus 16.55 on the right. And you can pick any two of these to solve it. Just looking at them, it should be apparent that you would take the I equation and the j equation because they're not coupled. The I equation has only y in it, and the j equation has only x in it. So if you solve it, you'll find that x is equal to 4.73 feet, and that y is equal to 7.78 feet. If you solve the third equation, it would tell you the same thing. So point P, having coordinates of x, comma, y, comma, 0, would be equal, or z, let's call that a z, would be equal to 4.73, 7.78, 0 feet. All right.